Hi guys, this is an honors credit video. So this comes from, if I can get that pushed up, this comes from 2.8. So we are not doing any of 2.8 in class. It basically is something that you only need to know if you're going to be going on to calculus. So even if you're not and you're just trying to get honors, sorry, you still have to do it. But if that's something that you're ever going to pursue either next year, taking AP Calc at the high school, or going on to college is something that you'll need to know for calculus. So first things first, everyone's going to need a calculator. And of course, I just left mine at the back of the room. But everyone, oh, it's up here. Everyone needs a calculator. So again, if you don't have a calculator, you can go ahead and try Desmos.com. I also was told about an app called Calculate84, free app, download on your phone to get a graphing calculator. And I think that one doesn't have ads. I've tried using it just to make sure that everything was good, and I didn't have any ads pop up for me. So I think you're good there. After you have a calculator, we'll go ahead and get started. So what we're doing today is calculating quadratic regression models. So it sounds a little bit complicated, but it really isn't. It's all calculator work. Like you won't write anything down until the very last step. That being said, I have a printout of my notes. Like I'll have some on me if you want those for yourself. They're definitely not super neat. They're not like clean, organized notes. They're my own like scratch notes for myself. But it'll be helpful to have this written down. I'm going to switch you over to a table in a second that will be helpful to have written down. And then I have all the steps written down on there and like what you should be seeing. So I have handed these notes out to students before, like last year when we went over this, I handed this out to every single student so that we could just focus on doing the calculator steps and not writing things down. So if you want those, just let me know. I'll have them on me. But what this basically kind of is figuring out a line of best fit for a quadratic model. These are all going to be word problem scenarios. So all real life scenarios that happen. This is why it's a regression model. When we talk about lines of best fit, it's not going to be a perfect line that goes through every single point. This is real life data. So some of the points are a little bit off of the line. Some are a little bit to the other way of the line. Some fit directly through that line of best fit. So again, this is just a line of best fit, not an exact line of the function of all the data. So for this example, we're just going to do one. A study was done to compare the speed x, which it's representing the variable x in miles per hour, to the mileage representing the variable y in miles per gallon of an automobile. So the results are shown in the table. So let me slide you over to the table. Sorry about my drawing. Some kid did that. Okay. So this X column and Y, it's basically an XY table, right? Speed to mileage comparison. So what we have to do with this data is enter all of it into our calculator. So before we even get started on that, there's a few things that we have to check. One being our stat plot. So you're not going to be able to see my calculator like very well. I've tried, and let me try turning the light off. I tried all the things I possibly can to try to get it to work, and it just doesn't. You can't seem to see a calculator on a video. So this is about the best I can do. But we need to go to the second button, and then this y equals. If you see above it, it says stat plot. So what we should be popping up like a plot 1, plot 2, plot 3, plot 4. We are concerned with plot 1. So I need you to hit enter on that. And it opens you up to a screen where you can see you're either on. No, you totally can't see that. Okay. You can either see on or off. We need to have this flashing over the on button. Then secondly, we need to look down here and see that the first scatter plot graph is what's highlighted. If those two things are good, then you're almost good. We also need to say that, and you really can't see a single bit of this, you have an X list and a Y list. Your X list should have a L sub 1, Your Y list should have an L sub 2. So we'll get into that in just a second too, but maybe I can write it up here for you. Your X list should be L sub 1, Y list L sub 2. If neither of those things or one of the other is not true, come see me and I can fix them for you. So after we've done that, you can go ahead and do second quit. Go ahead and get out of that. Then we're going to hit this stat button. And you see edit, ... Go ahead and press enter on that. It pops you up to a list 1 and list 2. So you can see I already kind of had these two lists filled out. Okay, I have those two lists filled out. That's what we need you to do. So your X column goes into your list 1. Your Y column goes into your list 2. One thing to make sure of is if you don't go from list 1 to list 2, list 3, list 4, list 5, something's wrong with that calculator, go ahead and bring that into me and I'll fix that for you again. But you basically type in under L1 in that next row, type in 15, press enter. 20, press enter. And then you need to get all the way down to 75. After doing that, arrow over to list 2. 22.3, press enter. 25.5, press enter. You need to get all of this data put in down to this very last number. When you are done with that, you should have in the same row your last two numbers. If they're off a row, like if one row ends here and the other ends down here, you forgot some numbers. If you forgot numbers or you misentered any of your numbers, you're definitely not going to get the right answer. So it's really important to be careful and diligent when putting in this data. Arrow back through it, maybe just like scan back through it, make sure that there's nothing like, some people will forget to put in a decimal point or they'll put in just the 0 instead of the 40. So just scan back through it, make sure it's all good. You can pause me to take the time to fill all of that data in. As soon as you're done, go ahead and start the video back up again because we're going to keep going. So the way that we want to first view this, because later on we're not going to be doing just quadratic regression, we're going to go on to linear, exponential, quadratic, moving on to natural regression. I mean, we're going to do tons and tons of different kinds. So we need to make sure that this is a quadratic regression model. So what we want to do is press the graph button at this point, and you're likely popping up an XY normal graph. Because of that, we need to go to the zoom button and go down to zoom stat. It should be number 9. Okay, you can't see anything, I'm sorry. Zoom stat and press enter. Then you should be popping up a graph that looks like this. Let me erase this. You should see something that looks kind of like this. And this is definitely not exact, but it's me doing my best. So let's think about what a quadratic function looks like. A quadratic is something that either opens down in a parabola or opens up in a parabola. So if I were to put a parabola through these points, do you think that this is something looking like a parabola? And your answer is never going to be exact, but you have to think what function does this most closely model? It's not a line, because it's not a straight line. It's not a cubic function because cubic functions have another turn. It's not a quartic because that has even more turns. It's not an exponential. It's not anything else, right? The line of best fit will go through, of a quadratic, would go through most of these points. Because it kind of looks like it has that parabola-like shape, it's true, this is a quadratic function. It's closely modeling a quadratic function, which means we're going to calculate the quadratic regression of it. So you always want to just double check, like, am I good? Is this truly a quadratic? You can also figure out, like, if I had a point way over here, I'd likely be like, ooh, I think I may have misentered that point. So then you can go back into your list and say, Why did I have a point way down here? Did I mis-enter something? Go back and check it all and make sure everything's good. Once I've decided that it is in fact a quadratic function, I go to the stat button. I arrow over to calc and I go down to number 5 and it's quad reg, right? Quadratic regression, quad reg. On number 5, I press enter. It will pop you up to a dialog box that has X list, list 1, Y list, list 2, frequency list, nothing, store reg EQ, nothing, and then calculate. You can enter down. You can either arrow down or you can press enter, 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 enter until calculate's highlighted, and then go ahead and calculate. What you should be getting out is, and you can kind of see this over here, that y equals ax squared plus bx plus c. What they do is they give you what that function looks like. So this is truly a quadratic function. So then they give you what each of those variables are for your regression model. So variable A is negative 0.0082, C is 0.746, and, so that's B. C is 13.46. So they gave us what the function's equation is so that we can plug in each of our variables to that equation. So our actual regression model would just be plugging in or substituting my A for my A, my B for my B, my C value for my C. So my regression would be y equals negative 0.0082x squared. Replace B, so plus 0.746x plus my C, 13.46. That is my quadratic regression model. So one super cool thing you get to do, you don't have, oh, sorry, you didn't see a bit of that up there. One super cool thing you can do is go enter this into your y equals. So go to this y equals button, enter the function I just wrote up here. So negative 0.0082x squared plus 0.746x plus 13.46. And then go ahead and press graph. So on my function that you can barely, or on my calculator you can barely see, hopefully you're kind of at least able to see that now I have this regression line through these points. So what this is showing me is my regression model through all of the data points that I entered. So this can kind of show you like, wow, you found a line of best fit, or whoa, you didn't, you did something wrong. This is not going through any of the points. You totally messed up. So we can see that this line is going about right through all of those points, with a couple of ones that barely touch, some that don't touch, and some that completely go straight through it. So this truly is the line of best fit, or the regression model to this data set of points. So that's it. This is your final answer. I like you to do this last step to say, like, is my answer right? Did I get something close enough? You are going to have some data sets that are just off enough that when you do this line of best fit, it only maybe goes through a couple of points and then comes super close to the rest of them. But for the most part, you should see that line of best fit really fitting this data pretty well if you're using the right kind of regression model. So this again would be your final answer. This is one step to kind of check yourself and make sure that you're correct. Okay, that is all for this honors topic.